Hi, this is Mrs. Eggerding, and you're watching the first video for Unit 2. We're going to talk about absolute value functions and inequalities in this unit, and today we're going to start with the basic absolute value function graph. If you remember from the first unit, we started off talking about how you could define the absolute value function in two pieces. And we called the stuff inside, if we said if it was positive or greater than 0, the stuff inside stayed the same. Whereas if the stuff inside was negative or less than 0, the absolute value was the opposite of that stuff inside. Now, using this definition, we can go ahead and make a table of values for our basic graph. So I'm going to start with just using the -2, -1, 0, 1, 2. And the absolute value of these numbers are 2, 1, 0, 1, and 2. And you'll notice in my table I have this nice symmetry here where the values repeat around 0, 0. That is a characteristic of absolute value graphs. You will get that symmetry on either side. Now, as you graph these dots, you get a very nice shape, and it is a V. The absolute value function will always make the shape of a V. And in fact, each one of these lines comes from this piecewise definition. So for instance, y equals x is a line that has a slope of 1 with a y-intercept of 0. And since it's greater than 0, that piece represents the right-hand side of your graph. In the same manner, I can take y equals -x, which is a line with a slope of -1 and a y-intercept of 0, and that's this left-hand side where the x values are negative. So the absolute value graph is made up of two lines that meet at 0, 0. One with a slope of 1, one with a slope of -1. Now, the domain of an absolute value function will always be all real numbers, or -infinity to infinity. This means I can plug in any number I want for x, and I'll be able to calculate a value. The range, however, is limited to just positive values of y. So from 0 to infinity, or you can say y's are greater than or equal to 0. Intercepts. For the x and the y intercepts, the absolute value, it shares 0, 0 as both the x and the y intercept. So right here is all the basic information you need to understand about a basic absolute value function graph. Now, if I change the equation just a little bit to 2 absolute value of x minus 3, I'm going to have to make a table to talk about what changes are made to this. I'm going to start with my -2, -1, 0, 1, and 2. And if I plug each one in, so if I take 2 times the absolute value of -2 minus 3, that becomes 4 minus 3, which is 1. If I repeat it with -1, I get 2 minus 3 is -1. If I keep going on, plugging in 0 gets me -3. Plugging in 1 gets me -1. Plugging in 2 gets me +1. So if I plot these ordered pairs, you'll notice a couple of things happen. First of all, the vertex of my graph is no longer at 0, 0. Second of all, you should notice that these lines don't have slopes of 1 and -1 anymore. So we'll have to talk about what happened there. Domain, all real numbers. Range, well, it doesn't start at 0, 0. In fact, the y-coordinate it starts at is at -3. So I'm going to say it's -3 to infinity. Intercepts, well, I have a y-intercept, and the y-intercept is at 0, -3. X-intercepts, however, not quite sure. They look like somewhere they're between 1 and 2 and between -1 and 2. So we'll have to talk about how do I find those exactly because they're in between numbers. Okay. Now let's talk about why something's changed from that basic graph. Okay. If you remember from when we talked about graphing lines, we talked about how this -3 can take the graph and move it down 3. And that's exactly what's happened in this graph. Instead of being at 0, 0, this y coordinate has moved down 3. The other thing that happened is the slopes of these lines. If I start at this vertex, I go up 2 over 1, up 2 over 1. And that is coming from this 2 in front. So this 2 is what we call a stretch. It is called a vertical, S-TCH. It's called a vertical stretch, and what that does is it changes the slope of these segments. We'll talk more about these transformations as we talk more about these graphs in class the next time we see you guys. So, now we did start talking about the transformations, and here we have a generic absolute value graph with values of A, H, and K, and I want to talk about what each one does. The K on the outside will move a graph up or down. If this K value is positive, it will move it up. If it's negative, it moves the graph down. The value for H moves the graph left or right. Left is going to end up being a positive number. And part of the reason for that, if you look inside the absolute value, it says x minus h. Well, if h is a negative number, that means I'm doing the absolute value of x minus a negative h. And that's where we get left looking like a positive. Moving right, that h is a positive number, and so it ends up looking like x minus h, which is why you're going to get the negative. The A, well, the A will do two things. One thing it could do is it could stretch, or it could do what we call a compression. In other words, makes the graph a little bit fatter, the slopes a little bit smaller. And a stretch will happen when this A value is going to be bigger than 1, and the compression will occur when it's between 0 and 1. The other thing this A can do is it can do a reflection. Okay. And what a reflection means is it's going to turn my absolute value graph upside down. And this will happen if the value for A is negative. Okay. Again, these transformations are a little bit new for you guys. We'll talk about them all year long. So for now, just try to get the basic idea, and we can talk a lot more about it in class next time we see you. What this means is the absolute value function. We can say the vertex occurs at h, comma, k. So whatever those two numbers are, that's going to get us our vertex. Domain will never ever change. It's always all real numbers. The range, well, the range depends on two things. First, it depends if we have a reflection. So, if my A is a positive value, my range will be from k to infinity because my absolute value is opening up. If that A value in front is negative, that means my graph is opening down, and my range will be negative infinity to whatever that k value is. So the range gets a little bit tricky depending on which way this thing opens. Let's see a basic one and see how it works. So here we have inside of the parentheses, and if you want to rewrite it with a minus sign, this is x minus -3 and then -2. So this -2 that's on the outside, let's see if I can get a different color. There we go. -2 on the outside is going to move the graph down to the minus a -3. This is going to move my graph left 3. And what those two transformations do is it moves the vertex. And so instead of starting at 0, 0, I can go left 3, down 2, and that's the location of my vertex now. Instead of being at 0, 0, this vertex is at -3, -2. My domain, all real numbers. The range of this graph, well, I know it's going to open up, so my range is going to start at -2 and go up to infinity. So what's my table going to look like? Well, here is where this vertex comes in handy, because you want to build your table around this vertex. Meaning I want to start with -3 in the middle, build up and down from that point. You want this middle value to be your vertex. If I plug numbers in, such as, let's start with the -2. -2 plus 3 is 1. Absolute value is 1. -2 is -1. Plug in the -1, so I get absolute value of 2 minus 2 is 0. Because of the symmetry, I know I can draw my graph vertex at -3, 2, -2, -1, -1, 0, and you'll notice I have a slope of 1 because that's the a value in front. The a value is a 1. There is my v. From here I can name my intercepts. My y-intercept looks like it's going to be at 0, 1. My x-intercepts are going to be at -1, 0. And it looks like -5, 0. So what we want you guys to focus on for the couple problems we have are two pieces. Number 1, can you create a table? And number 2, can you find this vertex? In class, we're going to talk more about these other things, the domain, the range, the intercepts, and how all of it all works together. Okay, so on page 264, 5 through 11 odd, and then 41 and 42. And for each one of these, we want you to make sure you do a couple of things. Make sure you state what the vertex is. Use that vertex to make a table. Remember, inside your table, you want the vertex to be this middle piece. And then state the domain and range. We'll see you in class next time, and we'll talk some more about these graphs. Thanks a lot. Bye.